So your instructions are, imagine you are a manager at a major bottling company. Customers will begin to complain that the bottles of the brand of soda produced in your company contain less than the advertised 16 ounces. Your boss wants to solve the problem at hand and asks you to investigate. You have your employees pull 30 bottles off the line at random, and you ask your employees to measure the amount of soda in each bottle. Note, use the data provided by your instructor to complete this assignment. So hopefully your professor has given you that information. If not, ask for it. So you're going to write just a 2 to 3 page paper. Okay, it's not a big paper. So you're going to calculate the mean, median, and standard deviation for the number of ounces in the bottles. So that's here, this first bit of instruction. Load your data into Excel, use these formulas. Mean is the average, median is median, and standard deviation is stdev.s. Remember to start with the equal sign to tell Excel that you're doing a formula. So then the next part that you have to do is to construct a 95% confidence interval for the ounces in the bottles. Okay, 95% confidence interval. Some students will not have made it to confidence intervals by the time it's time to do this project. So here's instructions for how to do a confidence interval. So we're going to use norm.s.inv for 1 minus c over 2. In this case, that is 95 is 0.05 over 2 is 0.025. In this case, we have 0.025. So 0.95, 1 minus 0.95 is 0.05, divided by 2 is 0.025. And your Excel can find that for you, or you can use your ALEKS calculator, which you will have been doing quite a lot of. Then you need to find your margin of error. Since we have 30 data values, this is a large sample size, and so we'll use Z. That's the Z you just found, times the standard deviation that you found up here, over the square root of the sample size. Okay, square root of the sample size. Then to find your confidence interval, you simply take the mean minus the margin of error, will give the lower bound, and the mean plus the standard of error will give the upper bound of the confidence interval. Your next instruction is to conduct a hypothesis test to verify if the claim that a bottle that contains less than 16 ounces is supported. Clearly state the logic of your test, the calculations, and the conclusion of your test. Okay? So to make the hypothesis test, you're going to write your claim as an inequality. In this case, that the ounces in the bottle is less than 16. So your next step is to figure out which hypothesis is this. If it has an equals, then it is a null. If it does not have an equality, then it is the alternative. So in this case, it was said strictly less than, therefore this is the alternative hypothesis. And so H1 is mu less than 16. So, okay, so you have a null and alternative based on your claim. Okay. Then you need to find your test statistic, which will be Z, because of having more than 30. We have 30 entries. So the test statistic Z is X bar, which is the sample mean, minus the population mean, which is the claim, over the standard deviation over the square root of the sample size. Okay, so the sample mean minus the claim divided by the standard deviation over the square root of the sample size. These are just all the numbers that you got in the problem a little while ago. So then step 6, find your z-score for your significance level. There is not a significance level given in the problem, okay? So unless your professor gives you a specific significance level, use 0.05 because that agrees with the 95% confidence interval, okay? So compare your z-score to the critical z. So at 0.05, the critical z will be norm dot s dot inv parentheses 0.95. So that's going to give you your critical z value, where you plug in the if alpha is 0.05, then we're using norm.s.inv of 0.95. And then compare your z-score to the critical z. If your z is in the rejection region, reject. Otherwise, fail to reject. Where does your rejection region come from? The rejection region comes from the alternative hypothesis. Remember, in this case, the claim was the ounces was less than 16. So because it does not have an equality sign, it's going to be your alternative. So the ounces in the bottle, since it says less than 16, then it's going to be it does not have an equality, so it is the alternative hypothesis. Therefore, because the alternative is less than, this is a left-tailed test. This is a left-tailed test. Okay? Because the alternative, I don't know, somehow I erased it without meaning to. We're going to use the same value as is given so that we can get the left tail. Okay? Now we're doing this in Excel unless you're comfortable enough with the ALEKS calculator. You can use that as well. But since you're going to load all your data into Excel in order to find your mean and standard deviation and median, then you might as well use it for it all. So your critical z is going to be norm.s.inv. This is in Excel. Or you can find on the ALEKS calculator z of 0.05. Compare your z-score to the critical z. If your z is in the rejection region, then you're going to reject. Otherwise, fail to reject. So the rejection region is going to be on the left. It's going to be a left tail. If your z is down in the left tail, then you would reject. Otherwise, you'll fail to reject. And then from the instructions, you're going to, once you actually conduct the hypothesis test, then you're going to discuss if you conclude that there are less than 16 ounces of soda, speculate on 3 possible causes. And next, suggest the strategies to avoid the deficit in the future. Or, and only one of these is going to be the case, if you conclude that the claim of less per bottle is not justified, provide a detailed explanation to your boss about the situation. Include your speculation on the reasons behind the claim and recommended one strategy geared towards mitigating this issue in the future. In other words, how can you keep people from thinking that you're cheating them on soda if you're really not? If you are cheating them, then how can you, what might be the causes? So it depends on how yours comes out. Like I mentioned at the beginning, in my class I gave each student different data. So I don't know whether they're going to, each student might find that they are, one student might find they are cheating the customers, and another student might not have them not cheating them. Okay? You need 2 quality resources, one of which can be a textbook. You're going to use in-text citations and then list the references at the end. You're going to type double space, Times New Roman, 1-inch margins, and APA. And then you're going to include a cover page containing the title, your name, the professor's name, the course title, etc., etc., etc. Okay? So click here to view the grading rubric. That's one of the most important things for a student to do, is to make sure that you know precisely how these things are going to be graded. You want to make sure you max out all the points that you can get on something like this. This doesn't have a whole lot of math. It's more just a few steps of the math and then writing it up. If you're having trouble with a confidence interval or a hypothesis test, you can always pull up your very best friend on YouTube and have YouTube step you through the process. Type in YouTube, into YouTube, type in confidence interval Excel, and it will show you exactly all the steps to take to calculate a confidence interval, and then do the same thing with a hypothesis test. So here's the rubric. There are 9 categories, each of which carries like 15%. Nope, they're different. 15% to calculate the mean, median, and mode. 20% to construct your confidence interval. 25% to do your hypothesis test. 15% to talk about the causes of either the skimpy soda bottles or the impression of skimpy soda bottles. Your writing is 5%. Your support, which means reasons or evidence that logically support your ideas, that's 5%, and your grammar and mechanics are 5%. The integration in your, plagiarism, failure to use in-text citations, read all of these things, see the point values, and just make sure you cover them all, okay? Make sure you cover every piece of this so that you can get all 140 points. That's almost as many points as your final exam, okay? So it's something that's really worth taking the time on. This is the week 10 project. So it'll be due on Sunday. Part about concluding that there are less, you're going to include your calculations, you're going to include the answers to each of these questions. It's double spaces. It's not